Welcome students. So today we are going to discuss the topic types of operating system. So let us see how many types of operating systems are there. So first is batch processing, second is real time, third is multiprogramming, fourth is multiprocessor operating system, fifth is distributed operating system, sixth is time shared operating system, and the last is mobile operating system. So one by one we are going to discuss all of this operating system. We'll understand what are the advantages, disadvantages of each of this operating system. So let us start with. So batch operating system is what? The users will submit their jobs and these jobs will be grouped together, which will be known as this batch. Batch means what? It is nothing but a group of similar jobs, and this programs or jobs of these input users are given to operators. Operators will then feed these jobs into the computer system for processing. Here, since the jobs are executed in batch, once the setup is done initially, then for later on programs there is reduction of time and setup operation, and due to this multiple programs can be executed with the same setup. The drawback of this system is that the user do not interact with the computer directly. It will just submit its job to the person named as operator, and this operator will give this job to a software which is called as monitor, and this monitor always resides in the memory of the computer system. Now let us understand what are the functions of monitor. So first function is obviously accepting the jobs from the user. Then it will set up the job for the first time, means like say suppose if you want to execute the COBOL program, then the system needs to set up the environment for executing the COBOL program, like setting up its loader, linker and all that stuff. Then at the end of the job, monitor terminates the process and transfer to the next job. At the end of the batch, the monitor will terminate the entire batch and then transfer to the new job. So let us see one diagram to understand this. So say suppose n number of users are there and each wants to execute the job. So these jobs will be given to this operator. This operator is nothing but the middleman, and what this operator is going to do is that he or she will group the jobs according to the similar needs. Like say suppose this first batch will be executing COBOL programs, okay, and say suppose this second batch will be executing the programs related to Fortran, and then these batches will be given to the computer for execution. Now let us understand the advantages of this batch operating system. Like I already told you, the setup time is reduced as we have to do the configuration for the first job initially only, then the later on jobs are executed smoothly. And since multiple jobs are executed one after another in a batch, obviously performance is increased, and this type of batch operating system was useful for billing and the banking application. Now what are the disadvantages of this batch operating system? So first is, as you can see, there is no direct interaction between the user and the computer, right? Once the user has submitted the job, then obviously suppose if in later on time he changes his mind regarding the job, so once he has submitted the job, he cannot make the changes. The operator will feed his job into the system, and hence the interaction is not directly possible. The second disadvantage is that it is very difficult to provide security because multiple users programs are grouped in this batch. So there is no individual security provided, and you also cannot execute the job based on their priority. Means all the jobs will be executed as per their submission into the system. And the last disadvantage is that the CPU time is not properly utilized, because the time during which this operator will collect the jobs, it will group the jobs, it will set up the environment, till that time computer will be idle. Hence we are saying that CPU time is not properly utilized. So this was all about the batch operating system. Now the next operating system that we are going to discuss is a real-time operating system. Now, as is the name, this particular operating system has to produce the output within a specific amount of time. Means within finite amount of time, the system has to produce the output. Now, these are usually the dedicated embedded system, and they are suppose they may typically read from and react to sensor data. The system must guarantee response to events within the fixed periods of time to ensure the correct performance. And there are two types of real-time operating system. First is the hard real-time operating system. Here the response time is absolute value and task must finish within the deadline, right? And second type of operating system is the soft real-time system. Here the response time may be average and the task may finish within the deadline, or it may take some more time. The only thing is that job will be executed, but a little bit of delay could be tolerated in soft real-time system. Now let us see some real applications for this. So this real-time systems could be used in medical application, robotics and automation, web-based application, virtual reality, and as is evident here, the direct interaction is possible between the user and the application, which was not there in the batch operating system. And but this type of real-time operating system may lead to certain faults and some security issues as well. Now let us dig into the types of this real-time operating system, and I will tell you some examples for this. So as I already told you, this hard real-time, it has to guarantee that the critical tasks are completed within the time. Then here secondary storage is limited or is absent, and since most of the code or data is kept in the read-only memory. This system may conflict with the time sharing system and is not generally supported by the general purpose operating system. Advanced operating systems such as virtual memory is also absent in these types of operating system. Real-time examples could be the satellite application or the flight control system, where the system has to give response within the finite amount of time. One more real-time example I could give is the recent launch of the ISRO to the Mars, isn't it? So there the rover was supposed to land on the Mars, isn't it? Which actually, unfortunately, it didn't materialize, but this is also one example of hard real-time operating system. Now let us move to the soft real-time operating system. So compared to hard real-time, this is less restrictive, and all systems tasks are completed, and maybe little bit of delay could be tolerated. And if say suppose a critical real-time task is there, then it will get priority over the other jobs. And this soft real-time operating system has limited utility in industrial control of robotics. One example of this soft real-time is the audio and visual system of our computer system. So this could be one example of soft real-time operating system. Now moving ahead, let us see the multi-programmed operating system. So in this, what actually happens is that in our RAM or our main memory, instead of keeping only one program at a time, multiple programs could be kept there, and they are supposed to be executed one after another. And here, once the user has given the job, the user interaction is not possible. And this actually was devised so that instead of uniprogramming means what? In RAM there will be only one program for execution, right? So suppose this is our RAM. So in RAM, some part will always be occupied by the operating system. So what happens in uniprogramming? At a time only one program will be residing, and due to which what will happen? So say suppose if this program desires input output operation, so then it will go on performing an input output operation, and till that time CPU will remain idle, isn't it? So to overcome this multi-program operating system was devised, right? So that our CPU will remain busy all the time. And here, depending on how many programs are kept, that will decide the degree of the multi-programming. Means say suppose if 4 jobs are kept in main memory, then you could say that the degree is 4. Like say suppose, like I have explained in the earlier slide, some part of RAM will always be occupied by operating system, and here in this example we have kept 4 jobs, and these jobs will be executed one by one. So let us try to understand the advantages. So here, since multiple jobs will be executed, obviously the throughput will be increased, then response time is also good, and performance of CPU is increased. And what about the disadvantages? So here, to handle all these multiple jobs in the main memory, we have to manage it properly. So hence memory management is required, and as well as maintenance is also required, and the tracking of jobs is to be done so that the system will know which job is to be executed and which job has been completed. So this was all regarding the multi-program operating system. Now moving ahead, we will discuss now multiprocessor operating system. As is the word, here multi means what? Many. Processor, so here obviously many processors will be there. So if there are more than 2 or more CPU within a single system, we would consider it as multiprocessor. And what is the significant thing about this multiprocessor system? They all share the system bus, memory and other resources. And since multiple processors are there, maximum work is done in the shorter period. And as you know, data is kept in the main memory, and that memory will be shared. Hence, the duplicate of data is avoided. Here, what is the advantage of having multiple CPU? So, say suppose if due to some reason one CPU fails, then the system will not halt. CPU will communicate with each other, and the system will keep on working, excluding the failed CPU. Here, 2 types of multiprocessor system are there. One is a symmetric. So here, same processor share memory is there. And what about asymmetric multiprocessor? Here, different processor do not share the memory. So let us see one diagram for this. So see here, different processors are there, but they are sharing the same memory, isn't it? And each CPU has its own register and cache, but they are using the same RAM or same memory. Now let us understand the advantages of this system. So since multiple CPUs are there, so more work is done, hence our throughput is increased. Then as I have already told you, like say suppose if something happens to this CPU, then the other two CPUs will keep on working, and hence the reliability of system is increased. And since we are including multiple CPU within the same system, so instead of having 3 computer system, we are having only 1 computer system, hence our hardware cost is reduced. So what about the disadvantages? So since we have to integrate all the 3 CPUs in the same system, then obviously the design will be complex, and the CPUs are not very cheap. So CPUs, the cost is also has to be considered when designing the multiprocessor operating system. And the last disadvantage is that not all operating systems support multiple processors. Moving ahead, next operating system is distributed operating system. So here, as the word is distributed, so what is happening here is that the number of computers are connected to each other using cables for sharing and communication among each other. Means over a wide area, these computers may be distributed. And different applications, process or programs are available on different systems, and this actually concept was introduced to overcome the centralized operating system concept. Let us see the applications of this distributed operating system. Like say suppose student information system is there, or rail reservation system is there. Now to understand this concept, observe this particular diagram. So like I have already told you, to overcome this centralized architecture, this distributed architecture has been devised. So see here, there is only one central server and multiple terminals are there. So here you can see that at different locations the servers are distributed and multiple terminals are connected to each of these different servers, right? So such type of architecture is called as the distributed architecture. So let us try to understand the advantages. So obviously the first advantage is that throughput is increased, and reliability is also increased. Hardware cost is reduced, right? Then what about disadvantages? It is complex in design, and plus to enable the communication between these different servers, obviously networking is required, right? So this is all about the distributed operating system. Now here one more architecture of distributed operating system is there. So like here you can see a communication network is required between the different units of this particular system. So say suppose here CPU, disk, memory is there. Here maybe only CPU and memory may be there. So likewise, so the system is widely distributed, and they are all connected together by using this communication network of cables, right? And that is why we have written that networking is must in distributed operating system. Time shared operating system. So what happens in time sharing system is that this system allows many users to share the computer resources simultaneously, and this actually means that the computer resources will be given to different programs according to the time slots. This is facilitated by giving equal time slots to each individual user for execution of the program, and due to which what will happen is that the context switching may take place if the job is not completed. Means say suppose user 1 is there, so suppose his job is there J1, so after his time slot is over, the job will then be, the system resources will be given to the next job. So this will require some context switching, and you have to pass the control from one process to another. In case any process does not complete its work within the time slot, then extra time is not given, but in the next execution cycle, that process or job will get the time slot for executing its job. Means for example, say suppose you are giving a time slot of 10 seconds, and say suppose first process is there, so maybe it requires 11 seconds to complete, so it will be given only 10 seconds to complete, and when the next execution cycle takes place, then 1 second will be given to this process P1 so that it will be executed completely. Now this actually time slot which is given to the processes is nothing but the time slice or the quantum. Now here consider the diagram for this. Like I have told you, the CPU, it will be given to all the different users based on the time slot. Means say suppose for example, let us consider that each user gets a time slot of 10 seconds only. So each user will get time slot of 10 seconds, and then next person will get the time slot. So in this way, in the round robin manner, the job will be completed. Okay. Now next operating system that we will consider is the mobile operating system, which is very popular. So the most popular mobile operating system are Android, iOS, and little bit of Windows system. And what are the different features of mobile operating system? So first is they are very user friendly. Plug and play compatibility is there. Then online compatibility is there, means they could be easily updated, and they all provide multitasking and multi-programming. And due to this mobile operating systems have become very popular. And there is a ease of updation, means every now and then every service provider provides the updates for its operating system. Next is the command line operating system. So these were used in the earlier era. So the first command line operating system is the DOS, that is disk operating system. Second is Unix, which was multi-user operating system, and the features of this are they are single tasking, and for every operation you have to write the command. May say suppose like I want to create a folder, then I have to write a command. If I want to delete the folder, I have to write the command. So like that. And this was not user friendly because end user cannot remember all these commands. So only experts or geek peoples could use this command line operating system. And since there was no GUI, that is graphical user interface, this command line operating system was restricted to only few people. Now if you compare DOS and Unix, Unix was earlier open source software and DOS was the proprietary software of the Microsoft. Now from command line operating system, next we develop the GUI based operating system, and most popular example is the Windows. Then Linux is there. Then the features of this operating system is, first is obviously multitasking, multiprogramming. These are very user friendly, hence they are very popular. It is GUI based, so very easy to operate, and due to this numerous reasons, this operating system become very popular. And in this, Linux is open source software and Windows is proprietary software. So this was all regarding the different types of operating system that are widely used. So this is all regarding the different types of operating system.